Hello, my name is Ryan Schumacher and I'll be presenting my project on coral health improvement for my food quality management course. The following slides will represent the defined phase of my project. The current problem with my Montipora digitata, hereon referred to as digicoral, is that it's in a poor state of health. There's been some significant die-off and no new growth over the past 3 months. Typically these coral are fairly hardy and grow rather quickly. My goal is to identify the optimum growth environment and water parameters to eliminate die-off and create visible new growth of at least 1/4 inch on my digicoral by the beginning of December 2016. In scope is my single Montipora digitata coral in regards to its health, including die-off and growth rate. Items out of scope include all other corals, fish, and invertebrates in the tank. The relevant metrics of my project are coral die-off and growth rate, measured in total inches of growth, starting on September 15th and ending on December 1st. My target is to eliminate die-off on my digicoral and get a minimum of 1/4 inch of growth on any single branch of the coral. Some of the strategic goals of this project are that the knowledge gained and procedures used while I'm improving my coral health I can use to implement on other corals in my tank. My project team includes the project champion, Dr. Helen Joyner, myself, the project leader, my project team members, Zoe and Steve, as well as Jessica Schumacher as my photographer. I've created a side talk table to describe the supplier input process customer relationship. This also contains a column to describe the critical to quality parameters. Along the left, first one there, we've got the tank heater providing input of electric heat to maintain water temperature in the tank, outputting a steady water temperature, customer being corals, fish, needs to be stable temperature within limits. Then me, the human, supplying fish food, which is the process of feeding the fish. The fish create excrement, and there's excess food there for the corals and the scavengers. And we need to provide complete nutrition without excess waste. Then we've got the fish and myself, the fish providing fish excrement, myself possibly excess food, feeding the corals in the tank. That output is then the energy of the coral, the excess nutrients, the customer being the coral tank, and the water quality. We need to provide complete nutrition of the corals without excess nutrients. Excess nutrients, as I will discuss later, can be a problem for water quality. Then we have lime quality, lime water, which is providing the alkalinity and calcium to the tank to provide good water quality for the coral mainly, and partly the fish. That needs to be stable and within limits. And last, we have a light fixture providing light energy, which is an artificial sunlight process for the corals, so that they have their energy for themselves, and there needs to be a particular light spectrum, intensity, and duration involved there. This includes a chart of my critical milestones and deadlines. Briefly, the project started at the start of class, August 22nd. I'm in the define phase, which started on the 22nd, running up until the beginning of the measure phase, which begins on September 26th. That runs for about a month, and then it begins running concurrently with both the analyze and the improve phases starting on the 24th of October with a goal of completion on December 11th. I've got several problems and some theories to discuss on what I might do to solve the issues. First being water temperature. Proper water temperature range is critical so it doesn't stress the corals and keeps in a range that maximizes the coral's metabolism rate. So I need to have good control of a water heater. I need to look at my feeding regimen to make sure that the fish and coral are fed enough to satisfy their calorie requirements, but they're not overfed. As I discussed earlier, uneaten food, when they're overfed, can be converted into breakdown products through bacteria and other mechanisms that are harmful to the fish. These can include ammonia, nitrates, and phosphate. So I need to determine a measurement or a way to find out when the fish are full. I need to also look at water parameters, specifically alkalinity and calcium. They're actually the building blocks of coral skeletons. Without them, the corals cannot grow. So I need a proper dosing regimen for those water parameters and a way to monitor them as I go. And then last, I'll be looking at light. Light actually provides energy for the zooanthia that in turn, through a symbiotic relationship within the cells of the coral themselves, will provide energy to the coral. So incorrect levels and spectrums of light will actually increase or decrease how they're living. So I need to look at the duration the lights are on, the type of bulb, spectrum I'm using, and the intensity. This concludes my presentation, and I'd like to invite everyone's comments and questions and constructive feedback. If you can leave that in the post, that'd be great. Thank you.